A research center estimates that 40% of U.S. adults eat breakfast every day. In a random sample of 300 U.S. adults, 135 say they eat breakfast every day. At the 10% level, is there enough evidence to reject the researcher's claim? What about at the 5% level? Use StatCrunch and the p-value method. So for this problem, we're testing a claim about a proportion because it's a percentage. So we're going to use p, and our claim estimates that 40% eat breakfast every day. So that's going to be equal to 0.40. Remember, we put the equality claim with the null hypothesis. That means our alternative hypothesis is not equal to 40%, and this is going to be a two-tailed test. We're going to then assume the claim proportion p sub 0 is actually 0.40. Our significance level at the beginning, we said, is going to be 10% or 0.10. So far, we have written the claim using our words, decided whether the claim went within null or the alternative hypothesis. We drew the claim arrow, and we used the null and the alternative hypothesis to assume the population proportion, and decide if it was left tail, right tail, or two tails. Next, our rejection criteria is going to be we're going to reject the null hypothesis if our p-value is less than or equal to our significance level. So our rejection criteria is of our p-value is less than or equal to, and our significance level in this case is 0.10. Now to find our test statistic. Our test statistic, since we're testing the claim about a proportion, we're going to use our z-test statistic. And we'll write down the formula from the formula sheet, which is p hat, which is our sample proportion, minus our claim proportion, p sub 0, divided by the square root of p sub 0 times q sub 0 all over n. In this problem, our p sub 0, remember, is going to be 0.40. That means our q sub 0 is going to be 1 minus p sub 0, or just 0.6. Our p hat, remember, is our sample proportion, and in this problem it says in a random sample 300 U.S. adults, 135 say they eat breakfast every day. So this would be 135 all over 300. Our n, remember, is our sample size, which is 300. Let's substitute those values into the formula. P hat, so 135 divided by 300, minus p sub 0, which is 0.6. Make sure you put parentheses around the numerator, divided by the square root. I'm going to put parentheses under the radical, p sub 0, which is 0.4, times 0.6, divided by n, and n, remember, is 300. Close my parentheses for the radical. So on our calculator, let's bring up the calculator here. On our calculator, we can go ahead and take 135 in parentheses, 135 divided by 300 minus 0.6, close parentheses. I'm sorry, that's not 0.6. That should be 0.4. 0.4. Let me change it over here as well. So this should be 0.40. Our claim proportion was 0.40, not 0.60. So it's 0.40. Minus 0.40, close the parentheses. Okay, go back. Divided by, and then we go second square root. And 0.4, let's open our parentheses first. 0.4 times 0.6 divided by 300, and then close our parentheses. So notice our parentheses around the numerator and around whatever's under the denominator, under the radical in the denominator. And I go ahead and hit enter. And I'm going to get a test statistic of 1.76. 0.7766953. Now, because this is two-tailed, remember this test statistic is positive or negative. On our graph, this is what it will look like. 0, 1, and 2. Negative 1 and negative 2. So negative 1.77 will do 2 decimal places. And positive 1.77. And our p-value is going to be the area in those two tails. This is our p-value right here. So the p-value is the area in those two tails, which we will have to calculate out. We can calculate it out using StatCrunch. So let's go to StatCrunch here. One way we can do it in StatCrunch is, remember, since this is a z distribution, we can use our z calculator. So stat calculator and our z, which is our normal distribution. And since this one is two-tailed, we're going to use the between feature. Our mean is 0, standard deviation of 1, and we're going to have to change our values here. Instead of negative 1 and positive 1, we're going to type in our values. Our first value is negative 1.767766953. Our other value is 1.7677666953. Lots of sixes there. Okay, and then we hit compute. Okay, so that's the area in between, but we want the area in these two tails. So remember from a previous chapter, we have to take and subtract that from 1. So on our calculator, we're going to have to take 1 minus our answer, 0.922900013, and hit enter. And our p-value is given to us. Let's write that down. So our p-value is 0.0770997. Another way we can check our p-value is using, again, the proportion statistics feature on hypothesis testing. So let's try that one now. Go back to StatCrunch. And now under StatCrunch, we can use the stat. Remember, we used proportion stats before. Okay, proportion stats, one sample, and with summary. Under that feature, we have the number of successes. In our problem, we have 135 people said that they eat breakfast every day out of a total of 300 people. A hypothesis test, remember our claim proportion is 0.4. And our alternative hypothesis, remember we said does not equal to, so we'll leave it there. And again, I like the optional graphs of the p-value plot. I like that one. So let's move this over a little bit more. And hit compute. So what does this screen tell us? On our screen, we can see several bits of information. Let's see. Our standard deviation, we can see our z statistic, and our z statistics, as you can tell, is the 1.767767. They round to a certain number of decimal places. Our p-value, again, is rounded to 4 decimal places, so 0.0771. So you can use either one of the screens. I prefer this screen. I think it's a lot more quicker and easier and more valuable. And then once we did the p-value plot, I can go ahead and hit the right arrow key, and it highlights the two tails that need to be shaded. It gives me my p-value and my z statistic all summarized there in one screen. Let's go ahead and write that p-value and make our decision. So remember, our p-value here is going to be 0.0771. Now our decision. Remember our decision, we have to either reject or fail to reject based on the rejection criteria from above. Remember, we reject if the p-value is less than or equal to 0.10. So it's 0.0771 compared to 0.10. If you want to add a couple more decimal places to make it a little bit more obvious, 0.0771 is definitely less than that. So our decision. If you're not sure what decision to make, remember we can also look at our steps for hypothesis testing. So these are the StatCrunch information here at the bottom of your hypothesis test worksheet. Moving to the next page, remember we reject the null hypothesis if our p-value is less than or equal to our significance level, which it is. So our decision for this one is going to be reject the null hypothesis. Now, our concluding statement. Our concluding statement, we have to look through these different options. So, does the original claim contain the condition of equality? Our answer is yes. Next, do we reject the claim? Our answer again is yes. So, our option is going to be option A. So, our sentence should look like this. The sample data does provide sufficient evidence to reject the claim that, let's see what our claim was, that 40% of adults eat breakfast every day. 40% of U.S. adults eat breakfast every day. And that's at the alpha equals 0.10 significance level. So it does provide sufficient evidence to reject the claim that only 40% of adults eat breakfast every day. It could be more, it could be less, we don't know. Now, let's test it at the 0.05 significance level. So if we test it at the 0.05 significance level, we look at 0.0771, 771 compared to 0.05. Going to add the couple decimal places, and we can see that it's definitely greater than. So this decision would be fail to reject. Fail to reject the null. So in this case, let me try and do a different color here. Okay, the claim contained equality, yes. Did we reject the null? No, we failed to reject the null. So this would be option B. So we would say then the sample data and then we would say does not provide sufficient evidence to reject the claim remember those are, so it does not provide sufficient evidence to reject the claim that 40% of adults, of U.S. adults, eat breakfast every day at alpha equals 0.05. So you got to make sure that probability value, this is kind of a higher probability value. For this case, 40% of adults eating breakfast every day, it may not be quite as important as some medical sort of study. which you would want a smaller significance. So make sure that you're testing the claim correctly. Our p-value is according to a significance level that's important for the situation.